Hey everyone! Today I want to talk about becoming an AI engineer, but with a realistic approach that acknowledges where most people actually start. There are tons of AI engineer roadmap videos claiming you can become an AI engineer in just a few months. As someone who does applied machine learning at Amazon with a focus on machine learning infrastructure and content understanding with Gen AI, I can tell you, for real, becoming an AI engineer at a major tech company takes significant time and dedication. But the good news is, you don't need all those advanced skills to start building useful AI applications. Most self-taught developers don't begin at big tech companies. They start with personal projects, work with startups, or build their own AI apps, learning as they go. So let's break down a more realistic roadmap that shows what you actually need at each stage of your journey. First, let's clarify what an AI engineer actually does, because many roadmap videos don't even describe the right role. They're often describing data science or traditional machine learning engineering. An AI engineer is not primarily someone who trains models from scratch like a data scientist or machine learning engineer would. Instead, AI engineers build applications on top of pre-trained foundation models like GPT-4 or Llama, focus on model adaptation through prompt engineering, RAG, and fine-tuning, prioritize scalability, evaluation, inference optimization, and real-world deployment, and handle end-to-end systems including security, data handling, and user feedback. This is a specialized role that builds on software engineering skills, but there are multiple entry points depending on your background. Let's talk about that next. Before diving into AI-specific technologies, you need some foundational skills. First, you obviously need some math fundamentals, so statistics, probability, and basic linear algebra will help you understand what's happening under the hood. You don't need a PhD in math, but you should at least conceptually understand concepts like matrix operations and probability distributions. Next, Python programming. You will need to be able to write production-level code even just to deploy your own AI applications. Strong Python skills are non-negotiable in the field. Relatedly, you'll need basic software development concepts, so version control with Git, command line basics, and understanding how to work with APIs. You'll need to know how different services communicate and how to manage your code effectively. It will also really help you to have some fundamental ML concepts under your belt, so even if AI engineers don't often train models from scratch, understanding the difference between supervised and unsupervised learning, basic model evaluation metrics, and concepts like overfitting and underfitting will give you the vocabulary to understand more advanced concepts. This foundation is crucial because AI engineering is fundamentally a software engineering discipline with a specialization on top. Without these basics, you'll struggle to make progress with more advanced concepts. Once you have these basics down, you can start working with AI tools and models. So first, you'll want to learn how to use AI APIs. Services like OpenAI's API let you integrate powerful models without needing to build them yourself. This is the fastest way to start building real applications with AI capabilities. You'll need to understand prompt engineering. Learning how to effectively communicate with AI models is a crucial skill. Well-crafted prompts can dramatically improve model outputs and are essential for getting consistent results. You can build simple RAG applications. This involves connecting AI models to your own data sources using vector databases and embedding techniques, so they can answer your queries more effectively. From there, experiment with different pre-trained models. Use resources like Hugging Face to access models others have crafted. This gives you experience with different model architectures without having to train or fine-tune them yourself. And finally, basic application architecture. You'll start learning how to structure AI applications with proper input handling, context construction, and output processing. At this stage, you're focusing on application rather than creation, using existing tools to build useful projects. This is where most self-taught developers start. You can create chatbots, content generators, simple classification systems, and other applications to solve real problems. If you want some help learning all the skills you need to start building your own projects, DataCamp offers excellent courses to help build your AI engineering foundation. For developers looking to integrate AI into applications, their Associate AI Engineer for Developers track teaches you how to work with OpenAI's API, Hugging Face, LangChain, and vector databases like Pinecone. Beyond that, you'll also learn prompt engineering techniques, LLM ops concepts for developing and deploying AI systems, building applications with LangChain for more complex AI functionality, and using embeddings in vector databases for semantic search and recommendations. For those with a data science background who want to dig more into working with foundation models themselves, the Associate AI Engineer for Data Scientists track helps you transition into AI engineering. You'll learn a review of machine learning fundamentals, deep learning with PyTorch, working with Hugging Face's model repository, fine-tuning foundation models, MLOps principles for reliable AI deployments, and explainable AI methods and responsible data management. Or maybe you're a complete beginner, in which case the AI Fundamentals track provides a no-code introduction to core AI concepts, including basic AI terminology and principles, how to use ChatGPT effectively, understanding machine learning concepts, large language models and how they work, generative AI concepts and application, and AI ethics and responsible implementation. These courses are great because they'll give you the foundation you need to start building real projects, which is the most important thing for learning. You'll also discover what aspects of AI engineering interest you most, so you can continue your learning journey. With your solid foundation and some real projects under your belt, you'll naturally want to deepen that knowledge. This is the perfect time to read AI Engineering by Chip Huyen, which covers everything you'll need to understand becoming a practicing AI engineer. Read the book and the references in the book, and you'll be well on your way. By the way, I've created a comprehensive 76-minute summary video on my channel that breaks down all the key concepts from the book, which you can read to prime yourself before reading and as a review after. As you build more projects and study resources like Chip's book, you'll naturally expand your skills to include a deeper understanding of deep learning, so the intricacies of neural networks, training processes, and how foundation models work. You'll learn about the transformer architecture, attention mechanisms, and how embeddings capture meaning. You'll also dig into deployment and infrastructure. You'll learn containerization with Docker and cloud deployment on platforms like AWS, GCP, or Azure. You'll understand system architecture, monitoring, and logging. There's also a lot more you can learn on RAG, so you can implement more sophisticated document chunking strategies, optimize embedding techniques, and understand the trade-offs between different retrieval methods. There's also a lot more to do with working with foundation models. You can master fine-tuning techniques like LoRa and make intelligent model selection decisions based on trade-offs between cost, performance, licensing, and more. You can build robust evaluation systems. You can create systematic ways to test model performance, measure hallucinations and bias, and implement both automated and human evaluation processes. From there, there's inference optimization. Make models faster and more efficient to run through techniques like quantization, distillation, and optimized deployment architectures. Or maybe agent systems, building AI applications that can break down complex tasks, use tools effectively, and maintain context over extended interactions. And of course, security, privacy, and ethics. You'll want to learn about implementing safeguards against attacks like prompt injection, ensuring privacy compliance, and considering the ethical implications of AI systems. At this stage, you're moving from simply using AI tools to understanding how they work and how to optimize them for specific use cases. The difference between a mid-level and senior AI engineer often comes down to mastery of these advanced topics. Without them, you'll struggle to build systems that can operate at scale or handle complex real-world scenarios. But with them, you'll be qualified for positions at top companies working on cutting-edge AI applications, positions that often come with salaries of $300,000 or $400,000 a year or more. There are many more specialized skills at this advanced level, from dataset engineering to application architecture patterns. I've created a comprehensive checklist that you can download for free at the link in the description if you're interested in seeing the full catalog of skills you need for professional AI engineering roles. As you can see from this list of really technical concepts, you're just not going to go from an absolute beginner to a professional AI engineer in 3 months. Here's a realistic look. So getting the basics and building your first AI apps. I'd say about 6 months of part-time studying. This assumes you're studying consistently and already have some programming background. If you're starting from absolutely zero, add another 6 months. Then becoming comfortable with more advanced concepts is probably another 6 to 12 months. During this time, you should be building increasingly complex projects and deepening your understanding of the underlying technologies. Reaching professional level competence would be another 1 to 2 years. This is where you develop the specialized skills needed for roles at larger companies or more advanced AI applications. And then becoming a senior or lead AI engineer at a top company where you'd really be earning $300K or more, an additional 3 to 5 years. Mastering the full spectrum of AI engineering skills and gaining the experience to lead complex projects takes time in the field. In total, expect a 3 to 6 year journey if you're starting from scratch and working part-time on your learning. Is that a long time? Yes. But it's also realistic. And remember, you can start building and potentially even working in the field much earlier. You don't need to wait until you've mastered everything. Is the commitment worth it? Absolutely. AI engineering is one of the most exciting and lucrative fields today, and it will only continue to grow. The key is to start building real projects as soon as possible. That's how you'll learn the fastest and discover what aspects of AI engineering truly excite you. Those who expect to become AI engineers in just a few months inevitably get discouraged when they discover the field's true complexity. But those who approach it with realistic expectations and focus on incremental progress often succeed and find themselves in high-demand positions that didn't even exist a few years ago. But I can already hear you wondering, is it really worth it with AI automation around the corner? My next video will be addressing exactly this question, so make sure you're subscribed so you don't miss it. Now, if all this hasn't scared you away, for those serious about pursuing this path, don't forget to download my comprehensive AI engineer skill checklist from the link in the description. It breaks down all the skills we discussed today, plus many more to keep your learning on track. Thanks for watching, and I'll see you in the next video.